Okay, welcome to your substitution video. These notes, the skeleton of the notes, are also on NetSchool on my website, so if you want to go ahead and already have the examples, the steps already be written down for you if you just want to work on the math throughout. Okay, so when we're given a set of linear equations, we already saw that we can solve them by graphing them or by looking at a table. Now we're going to look at substitution today, and tomorrow we'll look at elimination. So the very first thing you want to do is solve one of the equations for either x or y. It doesn't matter which equation, and it doesn't matter whether it's x or y. I would always go with the one that has a variable that doesn't have a coefficient. So here, if you notice, x doesn't have a number in front of it. That's typically the easiest to solve for because then you won't have any fractions. So that's what I would go with. So if we solve x, to get x by itself, we'd subtract 3y from both sides, so we'd end up with x equals 3 minus 3y. You could also have negative 3y plus 3. Again, it doesn't matter, just go with whatever easiest for you. Step 2 is you want to substitute this new equation into the other equation. So we're going to take our new equation of 3 minus 3y, we're going to substitute it in for x in my first equation. Because we know x is equal to 3 minus 3y, so we just substitute it into the first equation. Okay, now we need to solve. In order to solve, we're going to distribute, so we'd end up with 6 minus 6y plus 5y equals negative 5. Combine like terms, so you have 6 minus y equals negative 5. Subtract 6 from both sides, so you'd end up with negative y equals negative 11. Divide by negative 1, so you get y equals positive 11. Now you want to plug that answer into the equation you wrote in number 1 and solve for x in this situation. So we plug 11 into that 3 minus 3y. So we'd have 3 minus 3 times 11, just 3 minus 33. We end up with x equaling negative 30. So we'd have a solution of x being negative 30, y being 11. Again, you always want to check your answers. It's very easy to make a mistake in sign somewhere, so you want to check your answers. So all you do is you plug the x and the y back into your equation and make sure it works. So 2 times negative 30 is negative 60, plus 5 times 11, which is 55. Negative 60 plus 55 is negative 5, which works in this problem. Second equation, negative 30 plus 3 times 11, so negative 30 plus 33 is 3, which is what I'm supposed to get. Both answers check out, so my solution is negative 30, 11. Okay, our second example, we're going to start off the same way. We want to solve one equation for x or y. Here again, I chose the first equation because this x was already by itself. It didn't have a coefficient. Add the 2y to the other side and we get x equals 2y plus 4. Now we want to substitute that new equation into my second equation in this situation. So we plug in that 2y plus 4 in for x. We want to solve, distribute, so you get 6y plus 12 minus 6y equals 8. You notice now you've got 6y minus 6y, so we combine like terms, those y's go away. I'm left with 12 equals 8. Well, this is never true. 12 is never equal to 8, so since this is an untrue statement, we actually have no solution. And if you remember from yesterday, things that have no solution are when we have parallel lines. If you were to go through and put both of these into y equals, both these equations would have the same slope and a different y-intercept. So these are parallel lines that never intersect, so there's no solution. Again, if you get a statement that's not true, then that's when you have no solution. Our third example, if you can guess, probably will be our infinite solutions. So again, solve one equation for x or y. In this situation, y was already by itself, so it's easier to get alone. So to get y by itself, we need to add 4x to both sides. We'd end up with y equals 3 plus 4x. We want to substitute that 3 plus 4x into our first equation, so you always go into the other equation. You have 12 minus 3 times 3 plus 4x equals negative 9. Distribute. So you have 12 equals negative 9 minus 12x equals negative 9. Here my 12x minus 12x will go to 0, so we're left with negative 9 equals negative 9. Now this is always true. Negative 9 is always equal to negative 9. So since it's always true, we're going to have an infinite number of solutions. These two equations are actually the same thing. If you were to put them both into y equals, they would both be y equals 3 plus 4x or y equals 4x plus 3. They graph the exact same line, so they intersect at all points, which means there's infinite number of solutions. That's all for these notes. Please make sure that you understand. I would go back through and resolve example 1 take away all of my steps, rework it out yourself, and see if you can get through it yourself. The assignment is also online, the problem numbers that you're doing in your book, so if you'd like to go ahead and get started on that, you are more than welcome to.